Hey everybody, so today's function notation review, like I said, this is a skill that we should have mastered in Algebra 1, but even if you had, it was a couple of years ago, and again, my experience is that this is a concept that kind of escapes students. What is function notation? Why do we even bother? Well, it's a pretty big deal for transformations, to be honest with you. Function notation really is the key to understanding what transformations are telling you to do and what is actually happening. You got to know your function notation. So what is f of x? Now, I've kind of already clued you into this, and I told you that it's just a fancy way of naming your y values, but there's more to it than that. Maybe. Let's try again. There we go. So what is f of x? F of x is just a short name for an equation. This equation has x as its variable. So f is its name, and it's telling you that x is its variable, meaning we plug things in for x values. Like I could plug in x equals 3, or I could plug in x equals 0, or I could plug in x equals another equation. I could do that. So function notation names our equation, and it tells us that x is our variable. We see this next box is even bigger, so there must be more to it, right? It is a more detailed version of y. It tells mathematicians this function is called f, x is its variable, and anytime something happens on the inside, our job is to plug that in. So yeah, it's just the y values, but it gives it a name. You see, this way, if I put two graphs on one grid, I could say this one's graph f and this one is graph g. Because if they both said y equals, well, how would you know which one was which? Just by looking at the picture. That's too hard. So we typically would just put a letter right on the graph like you guys saw me do last week. I go, this is graph F, this is graph G, this is graph P. So I've got an example here for you. F of x equals x squared plus 3x minus 4. This is a quadratic, and our next two chapters are all about quadratics. So they're really, really important that you understand how to use them. If it says find f of 3, and this is the thought process that I need you going through. You've been told to find f of 3. Your job is to wonder, what changed from f of x to f of 3? And this is not to insult any intelligences. I literally want you asking yourself, if it was f of x and now it says f of 3, what changed? Hopefully it's obvious that the x has been replaced with a 3, right? You guys hopefully can see that. X has been replaced with a 3. So there's a 3 where x used to be. So what does that mean? These are the thoughts you have. There used to be an x there. Now there's a 3 there. What is that telling me to do? Well, if I replaced x with a 3 in the function notation right here, oh, that didn't work. Right here, so if x is replaced with a 3 on the left side of the equal sign, well, x should be replaced with a 3 on the right side as well. It means that you're going to replace all of the x's with 3's, and please do that in parentheses. This is substitution. You see, I plugged in a 3 where x used to be on the left side, so I need to plug in a 3 where x used to be on the right side. And, well, jokes, come on back. And I need you doing it with parentheses, meaning there should be a set of parentheses here when you plug in, a set of parentheses here when you plug in. Every time you have to substitute, you will use parentheses. We all cool with that idea? Folks at home, anything I can do for you? I'll be the only one that can hear you. All right. See, we're not actually going to do this question right now. I think we do it on the next slide. Can I clear it? No one will panic? Okay. So here I give you the exact same quadratic, x squared plus 3x minus 4. We're going to find f of 4x. Did it skip a slide? No. Okay, sorry. I thought I skipped a slide. What changed? This is the thought you should always be having. What changed? It's supposed to say f of 4x. Now it says it's supposed to say f of x. Now it says f of 4x. So what changed? You see, this time, there's more in those parentheses than just the x, right? If it had just said find f of 4, we would have just plugged in 4, and yes, we would have used our PEMDAS skills and we would have evaluated. So you're supposed to be thinking to yourself what changed. I don't need you to tell me. But what I want you to do is make a prediction. Just, again, I'm always asking you to think ahead. Make a prediction about what you're supposed to do. Here is what's going to happen. On the last one, everywhere there was an x, I replaced it with a 3 on the left side. So I replaced the x's with the 3 on the right side. I did that with parentheses. So what I'm going to do for this one is everywhere there used to be an x, I'm just going to go ahead and open up a set of parentheses. And if I fill those parentheses with a 4x on the left, you need to fill the parentheses with a 4x on the right. You see, parentheses are necessary. The students that don't use the parentheses right here will get a wrong answer. Because the students that don't use parentheses will say, oh, that's just going to be 4x squared. No, it's not. Because right here, your job is to square the 4 and the x. So what you would get is 16x squared. And then 3 times 4 gives me 12. So on my tests, if this was a multiple choice question, 4x squared plus 12x minus 4 would be one of the options sitting there waiting for you to choose it. Why do I do that? Because I'm some kind of big jerk? No. I do that because it shows me which students are not using parentheses. Now, I would make an answer choice like that be worth partial credit because I think that's fair. A student understood they were supposed to plug in 4x. Student forgot to use parentheses. Partial credit. But I will have those kinds of things on my test. I make wrong answers on purpose that tell me things because Blackboard gives me all the data I want, right? So I can go into Blackboard and I can say, what percentage of my students chose this wrong answer? And if the number's high, I go, okay, I have a misconception in my classrooms that I need to address. If the number's low, then we're doing pretty good. So it is still f of 4x. Before I move on to, so what do we do with stuff inside the parentheses? Are there any questions in my crowds? At home, folks? Understood what happened? Thumbs up if we're all good? Okay, 1 or 2 thumbs. All right, good. Out here, guys, anything I could do for you? Do you understand why this happened, what happened? Because this is what I'm asking you to do in your homework. Is that a question for me, Tex, or are you just stretching? Okay. This is what I'm going to be expecting you to do in your homework. You would show the work. Okay. So what do you do if you see stuff inside the parentheses? You see stuff inside the parentheses, and you will substitute for all your x variables in the equation. And the way that you're going to do it is you're going to open a set of parentheses everywhere there was an x, and then whatever stuff was inside the parentheses on the left, you're going to put that stuff inside the parentheses on the right. That's all you have to do. If I fill the parentheses with something, you fill the parentheses with something. It is that easy. Wherever there's an x, you must put parentheses. That's your only job. Wherever there's an x, you must put the parentheses. Then you get to fill them in. And then you let the math tell you what to do. And yes, this is really important stuff to transformations. And in this next box, I'm pretty sure I have something in all caps and bold, basically yelling about the parentheses. Yeah, there it is. Be sure to use the parentheses when you are doing a substitution. And I will tell you that there is one test question that shows up on Chapter 1 test, Chapter 2 test, and Chapter 3 test. The exact same question. I don't even change the numbers. And that question is designed to show me who's not using the parentheses when they should be. So please make sure that you're using those parentheses when you're doing your substitutions. It's unlocked. It's unlocked. So hopefully we're not confused about what to do when there's stuff inside the parentheses. Same quadratic, x squared plus 3x minus 4. This one says f of x, and then outside of parentheses, plus 5. So again, you're asking yourself, what changed? I know it doesn't say that, but you're asking yourself, what changed? And you're thinking, well, it looks like it just says add 5 to whatever f of x was. And they go, yeah, that's exactly what you're going to do. The new thought that I need you to start having, and I want you to have this every single time you see a change to your function notation, is, will this affect my x's or my y's? And how do you know? So, if I told you earlier that f of x is just a fancy way of saying the y values, what you can actually see this as saying, and thinking about it as saying, is y's plus 5. That's the thought you have. Oh, it says the y values plus 5. So will this affect the x's or the y's? Well, it's going to be the y values. Because it's happening outside of the parentheses, this is going to be changing your x values. And what is it going to do to them? Well, if it says y's plus 5, it's going to do exactly what it looks like. It's going to take all your y values and increase them by 5. So this will add 5 to the y values. All the y values. So that parabola, x squared plus 3x minus 4, it has a whole bunch of y values. And if you put a plus 5 outside of the parentheses on the left side of the equation, then you would have to put a plus 5 on the outside of the parentheses on the right side of the equation. So it would look like this. So I'm writing it in red to show you that that was the new thing. And if I added 5 to the far right on the left side of the equation, you're just going to add 5 to the far right on the right side of the equation. See, no parentheses is required for these x's because you're not doing anything with the x's. You're not touching the x's. What you're doing is adding to the y's. And your job is to think of all of this as your y values. You're adding 5 to them on the left, so you're going to add 5 to them on the right. X squared plus 3x, and then the negative 4 plus 5 becomes plus 1. There. New equation. That would be a new graph. Again, this is what you're going to be doing in your homework. So if you have any questions for me, now's the time to ask me. This way you have the ability to do your homework correct because, of course, the homework is due tomorrow. And tomorrow I'm going to be asking you to use this knowledge on transformations. This is your 1 day of function notation review because this is review. It's supposed to be review. No? Everybody's cool in this, huh? He says it's easy. Okay. You know, every year the students say it's easy. And then every year a whole bunch of people get half credit on this homework assignment because they're not doing what I'm asking. I need you guys to understand what's happening. So remember, just pipe up. Say anything. Anytime you have a question, just speak up. All right, fine. New example. This one says find 2 f of x. All right, how about this? We're going to start a script, something I do with my students every single year. When we're doing transformations, there's the same set of questions I always ask, and I think it's like 4 or 5 questions. And it starts like this. The first thing I want to know from you guys, and you should be able to just look at it, this change right here, me putting this 2 right here, is that an inside change or an outside change? And what I'm asking you is, did I change something on the inside of the parentheses, or did I change something on the outside of the parentheses? So I would say, okay, class, and when I address my class, I mean lots of people, so it would be great if I heard voices in the speaker that's on my ear and lots of voices out in the crowd because I need to know if we're understanding. Did this change the inside or the outside, class? And you would say, someone was going to say inside, but this 2 that's right here is definitely outside of those parentheses. So this is an outside change. This was an outside change as well. You see that plus 5 happened outside of the parentheses. Back here, come on board, there we go. This is an inside change because I changed something inside the parentheses. In this example here, that outside change affected the y's. Well, guess what? That is always going to be the case. Anytime you change something on the inside, you're going to be affecting, strike that, reverse it. Anytime you change something outside, you're going to be affecting the y's. Because remember, f of x is just a fancy way of saying y, and anytime you put a number in front of something in mathematics, it's telling you to multiply. So this literally says 2 times those y values. So whatever those y values were, you're going to multiply them by 2. So we say, will this affect the x values or the y values? This is going to affect the y values. And how will it affect it? It will double them, or it will multiply them by 2. All of them. Sneak peek. That would make this graph taller. If you think of your y value as your height, and then I doubled it, you'd be a lot taller, wouldn't you? Double tall. Yep. So if something changes on the outside, this is you changing the y values. Well then, if changing the outside changes the y values, what is changing the inside going to do? It's okay if you say it all. Everybody says it at once. What am I going to be changing if I change the inside? Whew. Okay. Silence. Crickets. All right, we'll try that one more time. All right, everybody. So we're going to clue in. These two guys are going to have to stop joking around. Yeah. If I change the outside, I'm changing the y's. So if I change the inside, what do you think I'm changing? The x's. There it is, okay? You do me a favor, poke him if he falls asleep, okay? Because if he falls out of that chair, I will be forced to laugh. That'll be the first thing I do is laugh. And then I'll ask, does he have a concussion? Great. Let's do something a little bit harder. Something that the students struggle with on this homework that you have. I'm telling you f of x is 3x minus 4. That is a simple straight line. And I'm asking you to find f of x plus 1. Hopefully you can see that this area has been changed. So from what I just asked you guys, that's everybody. Is this going to be an inside change or an outside change? Okay, this is happening inside the parentheses. Small mixed bag of answers, but mostly correct. This is inside. So earlier in the notes, what I told you was when you change the inside, your job is to replace all of your x's with parentheses and then do the math from there. Whatever I put in the parentheses, you put in the parentheses. Well, this is an inside change. So again, I'm looking for lots of voices because this lets me know if we're getting it or not. Unless you're wearing masks. If I change the inside, it affects the x's or the y's, class. Inside changes. So this is going to affect the x values. Let's go ahead and find f of x plus 1. Just like last time. Where there used to be an x, I'm going to put a set of parentheses. Let's fill those parentheses with x plus 1. On the right, I have a number on the side of the parentheses. Do you know what I'm supposed to do in this? Distribute. Someone said it. Yeah, distribute. You're going to distribute that 3. X plus 3 minus 4. So 3x minus 1. This round, I don't understand those parentheses. Like I could have just replaced x with x plus 1. Parentheses aren't necessary. And I go, okay. And this is wrong. Let's say you don't use the parentheses. There's the x plus 1. All right, because I showed you how to do it, and I showed you x plus 1. So this It's not. However, would be on my test the answer choices for you to pick. And everybody that shows the answer gets it. That's x plus 1. But that's too far to use the print. And you must use the you change your x's all the time. So the thing I just crossed out in red, that would earn you half credit. You don't have credit, you want whole. So just roll forward in stuff in what in the parentheses x you open parentheses and you fill those parentheses. Come on, active panel, catch up. So if there's stuff inside, you substitute that stuff inside. See how I put it in parentheses? Function notation. Parentheses into the equation with every single x. Come back afterwards, put in them, and then you do the math. And this, it doesn't say this, but this is, so I'm going to say, oh, come on now. Inside change affects x values. Outside. But addition. But I don't like to do 1 plus f of x plus 1. So if I do some addition and subtraction on the outside, then you should do the same. You would add a subtraction as well from the side of the equation. Basically, if you add f of x, say, plus 5, that plus 5 is new on the left side. So that plus 5 belongs on the right side as well. You know, if you do it on one side, you got to do it to the other. On the left side of the function, you saw a 2. If I put a number on the left side of the then your job would be everything by that number on the right side. 2 by 2. You can make sure that you multiply the entire right side by 2 is if you use parentheses equation and then distribute it. And since these are both outside changes, jokes, let's try that one more time. Effects. And that's the end of the notes, but I am going to, I'm just going to throw an equation out there real fast, and we're going to do 2 examples, just to make sure that we're fully understanding what's supposed to be happening, not hoping, in the homework. Can I clear without anybody panicking? Oh, wait. So today, what am I hoping that you got from this? I'm hoping that one, and understand what it is. You could look at it that changed the x's of the y's to that question. The only thing that we did today made I don't know how hand each algebra 1, but I do know that it's not. What? Okay. So let's just make an example. You don't have to, completely up to you. The skill. So we have f of x equals, how about 2x squared 5. Okay, so I've just made up some picture. Can we find, let's see what we want to do. How about negative 3 f of x? So if I say negative 3 f of x, again, I'm asking you to tell me inside change or an outside. Today. So change is bag, and that's for what this question is saying. Negative 3 times the y values. Notice is, let's write it in black, is that I dropped negative 3 on front. That means I literally multiplied the entire left side. It's an equation. It happened on the other. If you multiply the left side by negative 3, you had better multiply the right side by. But the only after the other side is a set of parentheses. Wrap the entire right side with parentheses and drop a negative 3 in front of it. Because then you distribute the negative 3. On my test, there will be the wrong answer choice of negative 6 squared plus 5. That answer choice, the student understood they were supposed to multiply the right side by negative 3. These parentheses are how important parentheses are. So we're going to distribute, get negative 6x squared, distribute, get negative 15. So negative 3 f of x is negative 6x squared minus 15. So like I said, if you'd written negative 6x squared plus 5, you would have earned half credit. But how about find, I don't know, f of, I like 3. Class. Inside change. Side. So answered. Including liners and 3. To change the inside, and most of the inside means I'm changing my. If you understand now. So what does it look like? Well, I put stuff inside the parentheses too. If I put stuff in the parentheses left side, that's my job. There's an X. Put it in parentheses. Wrap that. See, only X used to be here x squared, but it's not here now. They've replaced that X with 3x. Now, if you use the parentheses appropriately, not only will this x get squared, but so will this 3. So what you'll end up with is 2 times 9x squared. and then you get to multiply the 2 and 9. But 6x squared plus 5 would have been waiting for you on my test as a wrong answer choice. And 6x squared plus 5 is what you get to use the parentheses. Because if you don't use the parentheses, there is no application, it's not a distribution, there's no application of that exponent to the 3. And you would get 6x squared plus 5. Now that student would earn half credit, because at least that student understood they were supposed to be replacing the x with a 3x, but you don't want half credit, you want full credit, okay? So if you have any questions at all about what's going on, now is the time to ask. Don't wait until you get home and you're stumped. Ask me now. We'll you now. Crickets again. Okay, well, then I guess that means it's homework time.